Okay, sorry about that. Okay, let's go ahead and plug this back into the original equation, which was basically y double prime plus 3y prime plus 2y equal to 4x squared. But let's just see what the left-hand side does. Y double prime becomes 2c. 3y prime becomes 3 times the quantity b plus 2cx plus 2 times our original y for this particular solution, which is a plus bx plus cx squared. Okay, and now this all needs to equal 4x squared. Okay, if this is the particular solution, right, this is the solution that we should be able to plug into the equation and get it to equal to 4x squared. Okay, so let's go ahead and see what's going on. We have 2c plus 3b plus 6cx plus 2a plus 2bx plus 2cx squared equals 4x squared. And this is what I meant earlier about comparing coefficients, kind of like you did in partial fractions. On the right-hand side, bless you, you have one x squared term only, right? So if you compare the 4x squared, the 4 should be equal to what on the left-hand side? 2c. Does that make sense? And we do that for all the terms. So on the left we have a few linear terms, a few x's. On the right-hand side there are 0 of them. So that means that 2b plus 6c has to equal 0, right? So the coefficients of x, 2b and 6c, have to add up to 0. And then if I look at my constant terms, we have a 2c, a 3b, and a 2a. So 2a plus 3b plus 2c, those have to equal 0. And now we have a 3 by 3 system, although not a hard one, where we can actually determine what these coefficients are. So c would have to be 2, and then we can find b rather easily. What would b be? Negative 6. Plug these into b and c here. You get 7 for A. And we're done. So here's a solution. Okay, and we're being very loose with all the C1 labeling here. Okay, here's really what it boils down to. We have our complementary function, which we found earlier. And by the superposition principle, we just add on the particular solution, which according to these coefficients and according to this blue equation here, right, just plug them in and we're done. So A is 7, B is minus 6, C is 2. This is your complementary solution or function. And this is your particular solution.
What about the constants for the complementary solution?
Well, we don't have any initial conditions given to us, so we don't find them. Well, we can. You might have some in the homework. This particular example doesn't have any initial conditions. So if I did give you, for instance, that y of 0 was 1 and y prime of 0 was also 1, then we might be able to go ahead and find them. Okay? But you guys know, second order equation should have 2 constants, 2 parameters, right? Which we do. These over here, even though we call them constants, I mean, the best way to think about them is that they're and this is actually what it's called, undetermined coefficients, meaning that we are going to determine them, but they're not determined yet. And we can determine what they are by substituting them into the equation, comparing the coefficients on each side, and then they're not really constants anymore. It's actually a particular solution. Okay? Does that make sense?
Is it possible to actually find C1 and C2 though?
Right now, no, not without any initial conditions. Okay.